Okay, so we're going to make a real quick video today, and our video is about the idea of how do you simplify square roots. So before we dig into this topic, remember to square a number. To square a number means, right, to take a number and take it to the power of 2, which implies that you take it times itself, 5 times 5. So remember, these are our perfect square numbers. If 1 squared is 1, 1 is a perfect square number. 2 squared is 4, 4 is a perfect square number. 36 is a perfect square number because 6 times 6 makes 36, and so forth. And these numbers go forever, okay? All right, now, once you know how to square a number, remember then that we can work it backwards, and that is how to square root a number. So remember, if you take your perfect squares and you square root them, you go back to what you started with. So if I take the square root of 9, I get 3. The square root of 25, I get 5. Everybody knows this. This is an idea that you learned back in middle school. But what about a non-perfect square number? Right? I can take the square root of 25 and say it's 5, but what about the square root of 20? That is not a perfect square number. So what you've been taught to do is just to use a calculator and to get what is called a decimal approximation. And so really what we can do is we can say, well, square root 20 is about, remember that's the symbol for rounded, or about a 4.4721359, and it goes on farther and farther and farther, but it's approximately. And then you run into the, well, should I round it to the nearest whole number? Should I round it to the nearest tenth? How many decimals should I take it out? And we get into this idea of an answer that is not exact. This is an approximate answer. So what we're going to learn how to do is what's referred to as simplify a square root. Have you ever done it on a certain style of calculator and you go get the square root of 20 and you hit enter and your calculator does this, 2 square root 5, and you're like, what? Where did that come from? Okay, this is referred to as the simplified version of the square root of 20. And as mathematicians, you need to know how to go from square root 20 to 2 square root 5. All right, so let me show you a couple of ideas. All right, one thing to think about is 20 is made up of 2 different numbers. It's made up of a 4 times a 5. Well, okay, then the thought process would be, oh, square root 20 is similar to then taking the square root of 4 and the square root of 5. And then what's the square root of 4? 2 square root 5. That's where we're getting that answer, is because there is a perfect square hiding inside that 20. Now, that one was an easy one, but if I were to give you, say, and I'm going to get a new sheet of paper here, if I were to go say, let's go simplify the square root of 56, that one may not be as easy to say, well, what's the perfect square that's hiding inside of it? So the method that I'm going to teach you to do is to create what's called a factor tree. So you look at 56 and you start breaking it up into what times what, okay? And maybe you notice that 56 is a 7 times an 8. Okay, 7 is a prime number. It can't be factored down anymore, so I'm just going to underline him and stop him. And I'm going to take 8 and break him down a little bit more. That's a 2 times a 4. 2 can't be broken down anymore. And then this 4 can be broken down into a 2 times a 2. Now remember, a perfect square number is when you take a number times itself. So we're looking at the 7, the 2, the 2, and the 2. And look, I have a pair of numbers. That's like a little 2 squared is sitting right there. So what that means then, when I write my answer, okay, is that just a single 2 is going to come out front, and then this 7 and this 2 have to stay inside. So 7 times 2 is 14. So the square root of 56 can be simplified to 2 square root 14. Let's do another one. We're going to do several, and I am encouraging you to stop the video and try a couple on your own as I go to do them. So let's think about the square root of 18 and how it can be simplified. So I'm going to, again, model the idea of breaking it up, and we're looking for a pair of numbers. So let's see, 18. I'm thinking, oh, that's a 2 times a 9. That 2 can't be broken up anymore, so I'm going to underline him. 9, let's see, that can be broken up into a 3 times a 3. I can't break him up anymore. I can't, factor him out anymore. So I'm looking for a pair of numbers. Look, there's a pair of numbers. That's a 3 squared right there. All right, well, that means there's going to be a single 3 out in front, and then look for anything that doesn't have a pair. He didn't have a pair, so he's got to stay inside. 3 square root 2 is the simplified version of square root 18. We're just going to do several of these. Okay, I've got a couple more examples. Let's do the square root of 75. Okay, so again, start breaking it up. Let's see, and having a calculator next to you might help if you're not good with numbers, but I think this is a 3 times a 25. 3 cannot be broken down anymore. It's called a prime number, so I usually underline them so my eyes don't overlook them. 25 is not a prime number. I can break him up some more. That's a 5 times a 5, and those are both prime numbers. So I'm looking at the 3, the 5, and the 5. And I say, okay, well, look, I have a pair of numbers. I'm always looking for a pair of numbers. That tells me what is the number going to be out in front. And then see how this 3, he didn't have a pair or anybody to buddy up with, so he has to stay inside. Square root 75 is simplified as 5 square root 3. Okay, let's do another one. Square root of 72. Okay, so again, start breaking it up. What times what makes 72? How about a 9 times an 8? Okay, well, 9, I'm not going to underline either one of them because they're not prime numbers. 9 is a 3 times a 3. Okay, both of those are prime numbers. That 8 can break up into a 2 times a 4. That's 2 is a prime number. 4 can break up into a 2 times a 2. Those are both prime numbers. So again, the numbers that my eyes are looking at, I'm looking at this 2, this 2, this 2, this 3, and this 3, and I'm looking for pairs of numbers. Well, what's interesting about this is I see two different. I see a pair of 3s, so I know a 3 is going to come out in front. I see a pair of 2s, so I know a 2 is going to come out in front. Well, if a 3 is sitting out there and a 2 is sitting out there, I multiply them together. There's my 6, and then I have a single 2. He didn't pair up with anybody. He has to stay inside. 6 square root 2. Now, just to kind of reinforce that, another way to think about it is, guess what? 72 is a 36 times a 2. What's the square root of 36? 6. So see, that's just a 6 square root 2. But a lot of times kids can't see that there's a 36 in there, and that's why doing the factor tree is a little bit easier. Okay? All right, the last example I'm going to give you is an interesting example because will every single square root always simplify? And in a problem like this, when you start breaking this down, let's see, that's a 3 times a 10. 3 can't be broken up. 10 is a 2 times a 5. Well, look, I have a 5, I have a 2, I have a 3, but I don't have a pair of any numbers. I don't have another 3, I don't have another 2, I don't have another 5. So this one, it is already simplified. I can't simplify it anymore. There's not a pair of numbers or a perfect square numbers to pull out. All right, hopefully that was a pretty good little instructional video for you. Rewind it, listen to some of it again if you need. But on your homework today, I think you're going to have about 9 problems where you have to do this process. Make sure you do not just turn in the answers. Okay, we will not accept that. You do have to show us some work.